that out of the way. And here we go. Everybody have their, we're pretty much just going to use pencils and sticky notes now. Or pens, whatever you like to write with. So all we're doing is changing this original function into a transformed function and do what they tell me to do. So if you remember our general pattern, there's a multiplier on the outside that vertically stretches or compresses. Okay. If there's a multiplier on the inside, it shows it as a reciprocal. And then we have x minus h. And h is left and right. I'm gonna run out of space here. But it's crazy. And k is normal. This is up and down. So when it says right, the 2 goes in here. So all I have for the new one is 2 goes in next to the x as a subtraction. You just have to learn where the moves live. Okay? And it doesn't, it's easy learned, easy forgotten. So the more you practice, the more you're more likely to remember. So this is letter, get to should be letter D. What you guys got? Yep, okay. Now, unfortunately, this software diverges between this A and this 1 over B, and when that happens, I'll point that out to you, but there is just a little wiggle in what they do with these two. In our homework, A was A, no changes, B was crazy, it got flipped. In our, help yourself, those are all free to the public. Yes. Okay, remember this is a stretch, so it's a vertical stretch, so you're messing with A. So expanded vertically, so you're messing with the A. So our original was x squared. So if I'm going to expand vertically, that is the multiplier of A. So the factor of 3 is what's going to go outside original function. That's in quotes. In other words, it doesn't have a parenthesis around the x. It just goes no parenthesis. If it was inside, that would be the 1 over B guy. But outside, that's where A is. Now, but you got to notice the words. For this software, the words means whether you leave it alone or if you flip it. Okay, so that's crazy. Kind of a little interesting change than our homework. Our homework, you could always guarantee that was what you saw is what you put. So that is letter number 9. What'd you see? B? for you ladies who were gone yesterday, we're hiding the choices so we work harder to find the answer. Sometimes I just go ahead and look at the choices and say, oh, this doesn't work, this doesn't work, this doesn't work. So sometimes that's okay. And that's what you'll do tomorrow on the test, I'm sure. But this way, we're working a little bit harder on the review. Okay, number 10. Okay, when I showed you that transformation template there on number 8, I didn't note about the reflection. Okay, so if I reflect across the x-axis, that means A is negative. But they didn't have anything else besides, you know, they didn't say it was multiplied by a number other than 1. So what you're going to multiply, A, in this case, A is equal to a negative 1. So you're just going to write the new, and when you multiply something by a negative 1, there's nothing else there, you just write a negative sign. Okay? And so, see what I mean about the outside? Okay, that's outside. If it was inside, there'd be parentheses around it. But like D, you know, they'd have a negative on the inside of that. So that is the example of what it would look like if it said reflect across the y-axis. And we had those on our homework. So hopefully you're familiar with those. That's why it's a good idea to have get your homework done before the test. Right. So this was letter B. Left 3 units, that means H is a negative 3. Up 2 units, that means K is a positive 2. Because K is normal, H is crazy in the story. So I make my bar. I put a negative of a negative 3 means X plus 3. Just showing you the steps. You know, you guys would automatically go to this, right? And this is G of X. So what's D? That was fun. And as you look at your choices, you see it's obvious, isn't it? Pretty obvious, and I'm hoping you're feeling confident about the test tomorrow. If we can do it on a Friday before a vacation, I think we can. Yes, time off, yay. Always fun, exciting. I'm moving on. There's no questions. Okay, this one is where we get ishy, squishy, wishy, yicky, dicky, dicky, yucky. Okay. Now, how do I know when to leave it and when to switch it on this silly test? Well, the fact you're asking it to compress horizontally means you're talking H inside. Or not H, sorry, 1 over B. So when it says compress horizontally, that means B equals 3. So in the story, on the inside, so this is B, this is B. But 3 doesn't compress. So technically, it really compresses by the factor of 1/3. But they want you to write it. Okay, this is the one they chose. As if this inside number looks like it's larger than 1. Okay, so in this test, it's x cubed to begin with, okay? Horizontally makes it go on the inside, and the inside stayed looking the same. And that is not what we did on the homework. But the words told me it was inside. And so if you have a factor on the inside, you leave it the same. Because it's actually 1/3. Now, why am I making such drama? Because 13 says compress vertically. That means that's the A letter. But this word here, compress, doesn't match that number. I'm compressing vertically. That number is, A is actually 1/3. In order to compress vertically, A has to be smaller than 1. Now, what's going to save our skin is this second one. Translate left 3. That means H is a -3. So you look through your choices. I don't remember if A flips or not, because this is not the way the homework did it. You look for the one where it's X minus a -3 squared. So it's X plus 3 squared. And A is 1/3. That's our new function. So there's only one of your choices that has this. Which letter? Looks like B. That's right 3, left 3, right 3. No move, right or left. That's up 3. So that you might want to say that's up. This is right. This is left. And this is right. So because the only one in the, of your choices that has a left move, that's why you picked letter B. So we're fudging the counterfeit rule. I'm going to cover it up again. It's letter B. So watch the words. When you're compressing or stretching, when they stretch vertical up here, 3 stayed 3, right? Expand vertically means A equal 3. Expand stays. Okay, inside compress stays. Compress outside, we switch. And that is those monkey business. Monkey business. And it's all the way the numbers, but they want you to move beyond the numbers. That's the challenge. It's moving beyond the numbers, just seeing the big ideas. almost done with our 1.3 writing an equation. You had to do these at the bottom of your homework. You had to take your original, and then you didn't know what it was, right? This is your original. So to change it, to go left 3, you added 3 to the x on the inside, and you went down 3 to the h on the outside, or to the k on the outside. There you go. And then, that's all. So if you didn't know the function, that's what you'd type, but you do know the function. It's the absolute value. X plus 3 on the inside, minus 3 on the outside. So if you're working on 1.3 and you're not getting those equations yet, look at the book, see the examples. They don't tell you this part. They just tell you this part. But now we know it's an absolute value function, makes the v. This is it. And this is the next lesson. See that you understand this already. At least you're exposed to it. So it's letter A. See, B had a multiplier, that's no good. C had them going left and up, that's not what it says. And D had it going right and down. So watch out for the distractions. I just don't want to use them for the first thing. And you can, as you're working through that test tomorrow, if you've got time, you can go back and make sure you picked the one you wanted, that the other ones you didn't pick are wrong. Reflect across the x means A is negative. The outside, right? The negative lives on the outside. And translate right means h equals 3. So I put in, not a plus. X is crazy. That's your new function. This is transformation. This is not inverse. That's why we're not using that notation. We gave the transformation a brand new name. So that's reflect across the x-axis, and this example didn't have a y-axis reflection yet, so be ready, know what get your homework done so you have all the exposure to all the transformations. And this is right 3 units, and this should help you if you haven't gotten 1.3 done before the test. So letter 15 is letter D. What's that? Peekaboo. What could go wrong? Remember, these guys are the K's. There's a K, there's a K, there's a K. Nothing says up or down here. So bam, you could find the right answer right away. Super? Super math. I'm going to fold these up for the notebook. And we are skipping 16 through 19. They will not be on the test. I believe it'll just take us too much time. That was the composition function process, and I just don't think we'll have enough time for me to test you on that. And since you won't see it again, I'm good with it. As long as you know what to do it for the homework. I'll be happy. Happy. So, I took off one of the graphs in the front, and because there were 8 of them or something, right? 7 of them, so there'll only be 6 graphs, 8 of the equations, and then 4 inverses without graphs and 2 inverses with graphs. So inverse, remember the 4 steps? Use a 4-step process, or in my silliness, use a 4-step recipe. Change it to a Y. Solve for X. Divide by 3. And check to see, I don't know if they want you to divide 3 into Y and 9, but it doesn't look like it. Oh, switch the variables. And you can just stop here to look for this answer, because that turns into the inverse function notation. And it is letter C. Now that didn't take too long. That doesn't take near as long as these, that, you know, proving an inverse. So. But you got to be kind of sharp on the algebra steps, for sure. Change it to a Y. Subtract 1. I'm solving for X is what I'm doing. Remember how to get rid of the third. Times it by reciprocal, right? Both sides. Everybody gets a 3. Cha-ching, cha-ching. Please, oh pretty please, don't be like me. Remember to switch variables. Is that C? Yay. Okay. This turns into it's an F function, so now letter C. Well, was this one tricky on number 20? You see what they did with that X and that 9? That was tricky, wasn't it? You see that? See, the negative 9 was second in our story, and they had it first in theirs. Does that make you crazy? Don't let it make you crazy. At least it happened on the example, right? Algebra can be written a lot, you know. We wish math was all cut and dry, but there's still some pretty fuzzy places where you can take license and be creative and, yeah, do your own thing. That's what they did there. And you've got to be ready. That's what I like about these tests. They do set you up for success on the ACT because you've got to be flexible. Got to know everything can come in different forms. Okay. Get rid of the 3 first. That way your fraction's alone. That's what I would do anyway. Now here's a little trick. A little fraction trick. When your variable's in the denominator and you want him to get out of there, you can swap those two expressions. That's a shortcut. It makes life really simple. I like that move. You gotta get that X out of there sometime. So I isolate the fraction that has the x, then I swap them, so x shows up alone over here, and -4 with y minus 3 is in the denominator. It's algebraically sound. It's just a little trick, a little shortcut that saves you some time. And sometimes you get, in problem with algebra, sometimes you like get stuck in a rut. You just go round and round and round and you never get to the end like you want to. So that's that handy dandy. Now, I'm not sure. We're going to swap variables. And where does that negative go? Oh, they do have it out to the side. Okay, so this guy is here on the answers. Okay, fair and square. And this is G inverse of X. So now you know what to do when there's an X in the denominator. Most people just give up and walk away. I don't know what to do. So now you know. You know my secret. Ooh, I can do this. It's like a good chess move. Or a good tic-tac-toe move. I get to see my grandson in October, so we will have a challenge. I see my granddaughter on Sunday, so maybe I can teach her how to play tic-tac-toe and win. I'm sure her dad knows. Okay, what am I doing? I'm solving for X. X is in the denominator. Icky wicky. Move these two around. Like, remember which? There's a chess move I never did use much of. Can't remember the name of it. Any chess players in here? When you can switch two pieces, you can only do it once. You know, any chess players that do that? I have to ask Mr. Bell. Okay, so X plus 1 becomes the left side, and Y plus 2 is the new denominator. One last move, subtract a 1. So now we have swapped the variables, and who to guess, right? That this is the inverse of G. Looking at that, that looks crazy, doesn't it? It looks like, how did that happen, right? Well, the 2 was being subtracted, and it's being added. The 1 was being added, and it's being subtracted. The 2 was in the numerator, now it's in the denominator, or, you know, it was by itself, now it's in the denominator. The 1 was embedded in the fraction, now it's all by itself, so who knows, who knows? You know, it's hard to guess a pattern. 23, what do we got, D? There we go. Fancy D. Going back to the last 2. Oh, yes. Now, if you have the equation, you'll know the graph, right? So it's kind of like the last 2 we did, or the last 4 we did. It's just, it added in the graph. The key here is, remember, the graph has to be reflective across the y equals x number, or yeah, line, not number, not line, okay, number line. Anyway, it has to be reflective, and so if you are just playing the elimination game, which I'm going to do here, just for kicks, okay. A and B are reflected across the x equals y axis, but what about C? Nope. And what about D? See how this has extra parts on one side that aren't on the other side? See how this one has extra parts on one side and it's not on the other side. So this does not reflect. If it reflected, it would be a symmetrical relationship. Besides the fact, if I'm dividing by 7, my answer is going to end up showing multiply by 7. If I'm subtracting 29, my answer is going to show up adding 29. If I multiply by 3, my answer is going to show dividing by 3. None of the two that are left, one of the two that are left do not have 3, 29, and 7, and there's no way you can get those numbers from 3, 29, 7. So this is the elimination game. So this is the nope on this one. Therefore, it has all the parts of the inverse. I didn't take time to find it. You could. But if you see a symmetrical graph, a graph that reflects across the y equals x, and if you have matching values, you know it's true. And someone asked this morning, is that always true? Yes. It is. So you can just solve this one a little different way. It is using the answers, but it's kind of handy. So after what I told you, what's the answer to number 25? Is there a 3, 9, and 2 in the original equation? You see anywhere where they could get a 3, a 9, and a 2? Now you divide by 2, but you should have a 5 being subtracted somewhere, right? And where did this negative 3 come up? So that one's a nope. Here they're dividing by 7. You've got to have a 7 in the beginning to have it in the end. Nope. Okay, peekaboo. It might be, this is 2x plus 5, it might be this one by some magic. It might be, because the graph is symmetrical. So I would keep my eye on the prize. So the jury's still out on that one because, oh, wait a minute though. Well, if I divide by 2, the 5 might disappear. I don't know. We'll see. Let's look at this one. Okay, D. The graph is symmetrical. It reflects across the x equals y axis. So this is okay. See, C's graph was okay too. It just, I'm not sure about the equation. And so if you started out it looks like the 5 got subtracted, but everybody got divided by 2. So you might, yeah, this is the original. You might want to go ahead and play the game. Subtract 5. Get y minus 5 equals 2x. You still seeing me? Nope, sorry. Divide by 2, divide by 2. In number 24, they left this as the answer. And remember the ACT game? It could be that answer, or it could be 1 divided by 2 minus 5 divided by 2. And sure enough, that is, oh, I got to switch. I got to switch variables. So that's how they came up with it's D. And I couldn't cover these with sticky notes, so that's why I left that alone. Well, I could put 4 sticky notes if I wanted, but yeah, this is the H inverse of X. You guys feeling good about the test review? Watch it again. Think about it some more. Don't think you're done Remember, if all you do is it during this class period, it's never enough.